Welcome to another episode of We Are Carbon. I'm Helen Fisher and I'm joined by Marcus Jones to explore the role that our built environments can have in moving us towards a more regenerative future. Our homes, our offices, every construction that is put up to protect us from the outdoor elements uses considerable resources to build, maintain and regulate for our comfort. The idea of being regenerative rather than just sustainable with our buildings is a complex one. Directly healing the soil and ecosystems rather than just reducing our impact and extraction needs adds multiple layers for consideration. Though the topics are different, we can still find parallels between regenerative agriculture and regenerative architecture. Taking a holistic mindset, shaking up the ideas that we consider normal, recognising the value of diversity, the context of place, connecting the well-being of people to the environment, and not forgetting the power of local community and collaboration. These are all topics that could thread into any discussion on regeneration, along with providing for our needs from today's sunlight. That last one is a huge focus in Marcus's work, and through his varied career in the building industry, presently with his venture called Living Buildings, he's done plenty of out-of-the-box thinking on running our homes on the present year's sun. Regenerative architecture is a relatively small niche, but it belongs to some very passionate people and impactful developments. It was a huge pleasure to have this opportunity to delve into Marcus's work and thinking and gain insights into this piece of the regenerative puzzle. I hope you'll enjoy listening too, and check the description for a link through to an animation that I've recently created with Marcus. It brings to life a short overview of some of the concepts that we touch on here. New episodes of this podcast are added every other Tuesday. You can find them on YouTube and your favourite podcasting platforms, so don't forget to subscribe to keep up to date. Right, let's get stuck in. Hi Marcus, thank you so much for joining us today. I'm really excited to get stuck in and learn more about your work with regenerative buildings and how we can use the built environment as something that moves us forward sustainably. But before we get going, could you maybe offer an introduction to yourself and a little bit of background to your work?
Yeah, thank you. And thank you for the opportunity to be here. I kind of have spent my entire career in the building industry. So whether it was being a carpenter or demolition crew out of high school to becoming an electrician and HVAC technician in some way, like a student apprenticeship of that. And then all the way up through the kind of control side of things, understanding how the sensory networks that we install into buildings, and then into being able to help consult and design on buildings. So it's kind of been this holistic view that over the years, I didn't realize it when started out on the journey, but connecting the dots backwards, it's like, oh, you've really been able to see the majority of the systems that go into buildings, and also through the whole process, understand what isn't working great, and the changes that we could make. And then thinking of kind of tying biomimicry into it, how do we start to create buildings that are something that we crave to be in, that bring just like that mental calmness, health. You're like, oh, this is nice, it's well lit, comfortable. Unfortunately, I feel like most people today, or not most, but there's a good portion of people today that live in homes that, may be dark, or just, it was not thought of how to incorporate aspects of nature like light and, grounding or different things into it. So that's kind of what spurred me on in the last year and a half plus, is how do we start to implement or create those spaces and buildings that we would like to, just that we thrive in and that we desire to be in and spend our time in.
Fantastic. It's really exciting that we're getting to talk about something that's in many ways very different to what we usually talk about on the show. We talk a lot about the outside environment rather than the inside environment. But a lot of the language that you've just used with the biomimicry and the grounding and even our own personal health, as how that connects to those environments, they're very similar themes to what we might sort of already be discussing in different topics. Very holistic view of things. And I think it's going to be a great discussion. I'm excited to dig in and learn where we can see these parallels, but also learn something new and learn some new ideas to get us thinking. Before we talk about the buildings themselves, there's something that ties everything together very solidly, which is the idea of how we utilize energy, where that comes from, and how we put that to good use rather than something that isn't sustainable and is causing harm. So you've got a particularly interesting way of looking at this concept that really everything, I mean, it would be hard to say everything, but such a vast majority of the energy that we use comes from the sun. It's just that some of it is incredibly old, so fossil fuels, and some of it is there shining in the sky today. So that's a really interesting concept, and it helps us to visualize things. So maybe you could dive in with some of that and help us to view that a bit more.
Some of this idea came out of seeing those systems and seeing the complexity that goes into the systems, especially buildings that are supposed to be our ideal renewable energy buildings. It came to me in listening to some books around like systems thinking that like if you look at our system of the earth, and there's really only one primary input that comes into it. And when you start to connect the dots that sun has been here for billions of years driving photosynthesis on the planet, which was, plankton or trees, which eventually fed other larger animals, all created the fossil fuels. So it's just I heard yesterday that ancient photosynthesis is what we're burning today. And if you look at our lives, we rely on fire, whether it's burning something to drive a car, burning something to create electricity, burning something to keep us heated. There are systems that burn things to keep things cool, which is counterintuitive, but all of those systems, whether it's burning biomass, wood of some sort, or whatever, that's still the photosynthetic process over this period of time. And really, to me, it boils down to, instead of looking at an emissions target of how much carbon have we not used or we not burned, is we flip it kind of the other way and look at, isn't our ultimate goal to see if we can live off of the sun that lands around us in a 1 year time period, much like a tree? A tree and a building reside in the same place their entire lives. The tree is able to sustain its life off of the air and the rain, everything, the sun that falls upon it. And it has that local network of fungi and everything that ties it together. What about our buildings? Can they be able to sit in that same spot, collect water that falls, use it locally, and then also take that sun's direct energy in the form that it comes to us on the planet of heat and absorb that heat into the building and be able to store it for periods of time? And to me, that came up as that's the most simplistic way for us to be able to have renewable energy. And it's also the most resilient, because those buildings aren't specifically reliant. They'll use, but aren't reliant on the electric grid to stay functional. And that's kind of where some of that is, where that has kind of led me in this path of the built environment and how we get there.
Yeah, so when we think about the built environment, we're talking about energy expenditure both in constructing that building and then also in its day-to-day usage. And if we are to sort of break this down a little bit, because energy use in building and construction, it's a very, very big topic. And particularly if people haven't given any mind to it previously. So I think it would be really helpful if we could just focus to begin with on the construction side of things
Hmm.
and get a sense of how do we look at construction of buildings in a regenerative way?
Yeah, I think a lot of it comes down to making sure that the choices we make are last for multiple generations. So if one solution has the ability to take, uh, let's just say, some set amount of energy that we're talking about, one unit of energy that goes into a solution that lasts 1 to 2 generations, or if that same unit of energy could go into something that lasts for 7 or 8 generations, to me is one of the kind of highlights of making sure that should be the driving factor behind all of our decisions, because we're ultimately limited on the amount of stored up photosynthesis that we have available to us. So we really want to be concerned about ensuring that the decisions made today when we're investing a very precious resource, that we get that longer generation. So really looking at how far materials come from, trying to use as many local materials as possible, which may still extract a fair amount of fossil fuel energy, but one of the primary materials that is available to everyone around the world is one of the oldest building techniques is called rammed earth. And that's where you take some from your local quarries, sand and aggregate and cement, and you mix it up, put it into a formwork, and you essentially are creating sedimentary rock. And it's really beautiful. It's local. And that solution can, properly designed and constructed, can create homes and buildings that are able to store the sun's energy for long periods of time and then send that back out. So that's like the regenerative piece. It's highly energy intensive to quarry that rock, grind it up, put it into those forms. But once that form is there, it's the most simple system that can last 500 years. And it's the regenerative construction comes down from like the materials and just really ensuring that you have a holistic concept to start, implemented properly, and have that kind of process seen from start to finish to make sure that everything's working the way it's supposed to, and then that building is able to operate simplistically with local knowledge, local materials, not reliant on something that it may not be the perfect place thing that we're looking at today, but we can create that, a space that is comfortable always and be able to provide shelter and warmth to us year round without the possibility, or without, even if electricity is not available, like if the electric grid is not there and reliable.
Yeah. So when it comes to something like rammed earth, that is, everything you've just said, it makes me realize that we're not looking at a one side simple, this is the perfect answer, but that we can take a look at various factors and then come to a conclusion based on the given circumstance. So the localization, it's easy to see why localization in anything is going to be less energy intensive, because transportation, particularly of big heavy materials, that's got to be pretty consumptious, of fossil fuels, unless we've got sort of solar powered battery transportation, but that in itself poses its own questions. So localization, that keeps sort of a very simple box to tick, and we can probably look at identifying that in the sort of the materials chain. But then you've said the rammed earth, the actual processing of the materials to go into that, can be quite energy intensive. So it's not the perfect answer, but the longevity then is the additional box that's ticking. The fact that it's not going to last just a couple of generations, but it's going to be serving for generations to come, one after another, after another, after another. And I think maybe if we talk about the longevity a little bit more, because that is something that we have, it's sort of been thrown out the window in many areas of our modern economy deliberately. Because in a way, if you create a product that's going to last forever, then you've kind of put yourself out of business. You've sold one that customer's satisfied. So when we look at homes today, what is the actual lifespan that they're expected to live for, on sort of like just a general idea?
I mean, there are some homes today that are being deconstructed that aren't even 20 years old. And not just someone's house that they were living in with their family. That some of these houses are those, like in where we are in Vermont, there's a lot of skiing, and there are a lot of wealthy people that come in from out of state and have these massive houses to be able to go skiing at. And those, because they were, the idea was just to have this big, beautiful thing, and with some vision of what it looks, what beautiful is, but relying on construction practices that don't, were built for speed, not for longevity. So using 2x4 material, or just regular plank wood material, constructed in a way that just creates the visual of what's wanted, but not thinking about all the details of the insulation and that. So it's, those buildings are the ones that start to create mold for first. They have, just the mold is a huge issue. I think 50% of our homes have mold in them that we're living with. And so the longevity, all of those pieces come together. If we find mold, then we have to deconstruct even more, or demolish those buildings. And that kind of ties back to the longevity is tied directly to the resources, and using, like, you can reclaim old wood and it's in better quality than the newer wood from today's. So right now, a lot of these buildings are being deconstructed or just torn down and thrown into the landfill. And we could be capturing some of those materials to put into new buildings. That goes, so it's the local piece. And then when you design properly around it, you get the longevity to make sure that you're protecting those materials from the weather and from moisture, so that we have the buildings that are last longer and provide that health benefit too, of providing a mold-free environment for us to live.
Yeah. And when it comes to timber, you just made a statement there that I think is very interesting, that the reclaimed materials can last longer than the new wood. So this new fast-grown wood that feels like a sort of sustainable and renewable resource that's being deliberately grown for the construction industry, why does it not last so long?
Because it's grown so fast, you can, if you were able to look at the end grains of two pieces of wood, one that was grown quickly and one that was some of the original old growth forest, you'd see that the growth rings are significantly closer on the old growth wood. And then the new wood is just, it grows fast. And it therefore has less overall strength and density to it. So it tends to warp more. And then one of the big pieces is it doesn't last great if it's not put into that proper shell of a building that keeps moisture out. And that's the other piece, is we haven't really been thinking about, we often think about rain falling and keeping that out of the house, but there's moisture from us living in there that gets, there's moisture from us during the wintertime, moisture that's inside drives to the outside of the building. In the summertime, when it's more moist outside, it comes in, it finds all these little cracks and can find mold. In our house recently that we were renovating, we found mold in probably 4 or 5 different ways throughout the building from various water damage. Mold is a big piece that we've really uncovered, is how unhealthy our buildings are as well, through this, specifically last year, of going through it ourselves in our house.
I've heard this from quite a number of people, this sort of almost like an epidemic level of mold causing health issues. We know that within modern construction, we're very mindful to seal the building, but we're sealing with plastics. And when we think about mold and moisture, we think, okay, well, it's not going to live on a plastic environment. That's a good thing. That's going to protect it. But then you're talking about condensation and the moisture being created within the building itself. So I suppose this is about breathability at this point. It's the mold is a living, it's there because the environment's supporting it. there's something wrong, and it's not the plastic itself, it's not these sealed containers. So is it coming down to breathability of buildings that we've lost?
Yeah, that is a big part of it. As we start to seal buildings up, they certainly, that's when mold issues creep up more and more because instead of that whole building being leaky and, we start to make it airtight, then typically there are a lot of new systems that allow vapor going in and out. But the typical house out there that isn't new does have a lot more breathability. And it really, there's such a science to it that even I don't really fully understand, that rely on other people to really make sure that the moisture drive throughout a building is really thought out and not to make sure no moisture comes up through the ground. Um, but yeah, it's the plastics do kind of help seal it in, and one of our main solutions right now in that tighter environment is put a ventilation system into the building, which makes great sense. You can do it efficiently, air exchanges through the house and exchange some of the heat. But there are ways to also create passive strategies that provide ventilation so you aren't reliant on a more complex mechanical piece of equipment. You may still have a fan, but you could be bringing outside air into the building through a, a pipe in the ground that exchanges heat on its way in. So if it's 0 degrees outside, it comes through the ground, picks up heat, and then comes inside at a more reasonable temperature. So you can start to, it's looking at, and that creates that longevity piece. You're not relying on a piece of mechanical equipment to be able to do the same thing. If you design holistically all the systems so that maybe there's still a fan that's needed, but it's simplistic and easy to replace. It's something that's going to be available in the future, and you can start to minimize the resources and the maintenance things that go in to be able to provide that kind of ventilation to newer buildings.
Yeah, lovely. So if we go back to the rammed earth, because I think that's an interesting material to discuss, it just gives us so many sort of angles to go at this at. I'm thinking of a sort of standardized construction today to be fairly based on concrete, breeze blocks, steel, materials that have been transported a very long way. You mentioned that the rammed earth is fantastic because you can obtain that in the local region wherever you are, but that it still does require a lot of processing. How does that processing compare to concrete and steel?
So the processing is specifically in comparison to concrete is the best similarity because they both require essentially the same materials. They're just put together a little bit differently. Um, so in a concrete mix, you take sand, aggregate, and Portland cement and water, and they mix that up, and it comes out as a slurry that gets dumped into a formwork. Rammed earth uses a slightly different ratio of those components, but it uses the same components of sand and aggregate. And we're trying to find where you can use less Portland cement. So there are some possibilities to reduce the cement content by 50% while maintaining the same strength as high strength concrete. Um, so those are very similar. Where rammed earth is going to require more energy input is the installation of it is more time consuming and requires energy of running a air compressor to compact it. So it's a dry mix or just a damp mix that you pour in an 8-inch layer into formwork, and then you pneumatically compress it down to like 5 inches, and it creates that sedimentary rock instead of over thousands of years. You do it in hours in a form.
Yeah, you showed me a photo of this, and I just want to sort of mention because it's hard to get across. It's actually incredibly beautiful. It's compared to something like a concrete wall, which you can polish up and make quite a beautiful thing out of concrete itself. But this rammed earth, it just has a feel of something very organic, even though it's been manufactured. I think it would be interesting to sort of delve into this just a little bit deeper, because my thinking when I kind of go to local materials for building, I'm wondering about the idea of cob, and simply they're sort of obtaining clay and mud and utilizing that as a building material. Does that have less of a longevity than if you're constructing this more sort of sedimentary type material?
Yeah, so it has, there's a couple benefits to rammed earth over things like cob. And not that I would discourage cob at all. I think there's this mixture between using both, where um, something like cob or hempcrete that has maybe not as long of a lifespan, if we design our buildings correctly, that we can know that we're not going to be able to plan what that building needs to do 500 years from now. We can just know that it could be here in 500 years from now, but is it still meeting the needs of the occupants at that time? So planning the ability to make changes without tremendous effort for the next generation. So if you do, there's certain primary walls that you might set up as rammed earth that are the ones that are able to absorb that the solar energy and store it. And then you could have end walls that might be a different format of cob or hempcrete that you might say, oh, in 200 years, we may need double the space and we can expand out that wall. And you've already planned out what that site plan could look like for an expansion, even though you're not building that building. Um, so whereas like, yeah, the cob may require more maintenance, replastering every so often. When the formwork comes off of rammed earth, that is the wall. There's no interior finish that's needed. There's no siding. There's no treatment. You don't have to paint it. It is what it is. And as long as it's protected with an overhang and proper drainage, it will exist. And you don't have to, there's literally no maintenance to it.
Yeah, sounds very impressive. So it's sort of it's beautiful and it's the finished piece. And what about insulation value between them all? Because of course, if we talk about a modern building, we're going to be adding an additional material in. Something like hempcrete could perhaps be self-insulating. What about the rammed earth?
So rammed earth, you'd put insulation in the middle. So you'd have a wide form and then two walls on the one on the inside, one on the outside. And then there would be insulation sandwiched in the middle. And that's basically been determined to be one of the best performing wall structures that exist. And what makes that beneficial is the R value of the insulation when it's in between two thermal masses. These are huge, heavy, dense walls that are able to absorb a tremendous amount of energy on either side. Um, and that means that the insulation in the middle never sees extreme temperatures. So when we have a cold snap and it drops down to minus 20, the insulation on a standard house would see minus 20 and it would be trying to stop heat flow from minus 20 to your 70 degrees inside. Well, this building, it would have to be a sustained minus 20 for days or weeks before that cold seeps all the way through to the insulation layer. So you get a higher effective R value out of this wall performance. And then you have the benefits of the thermal storage, which allow you could have a sunny, a real sunny day where you allow a tremendous amount of sunlight into the building. And a typical, well, just high efficient building would get overheated and you would be opening windows and be too hot and say, we need to block the sun out. But if we have a thermal storage mass in that wall, it can absorb that sun from one day and the energy and store for a couple days or weeks, depending on how extreme the weather is. So it creates this really super high performing and a very simplistic system that doesn't have any moving parts. And you have pieces that'll have to help with that, and there will be some moving parts with it, but the general part of it is simplistic. It's like living in a cave that's a consistent temperature. You bring it above ground, and then you add the sunlight to it, but you have it insulated. So it's collecting that sunshine, storing that into the cave. And so instead of 55 degrees, it might be 68 degrees consistently, or slight variations from winter to summer, but not not drastic variations.
Yeah, I think there's something very cave-like about it, actually. It feels like it's, the longevity side of it, plus this insulation and this passively thermal mass. It just sounds like it belongs. The living environment belongs where we, to my mind, if you compared that to a standard modern home, the modern home feels a bit more like a tin can, like it's just been placed there. It's going to rattle around in the wind. It's not going to last very long, and it's also allowing the sunlight and the weather and all those temperature changes to just be sort of very quickly passed through into that internal environment. And this feels just sort of very much more grounded in itself. Just the material is so grounded, and that that insulation value of that rammed wall, where it's being constructed so that it's got the insulation in between, so it's like a cavity wall but made of rammed earth. Is there a particular type of insulation material that best suits that, or is it the wall itself that's making the difference?
It's primarily the wall itself. So you have to factor in how moisture plays in sealing different insulations to decide on each individual project. But quite often, what's used right now is recycled um, polyiso polyisocyanurate, which is a common roofing insulation for commercial buildings. So it's an oil-based product, but they take it off of roofs every time they do the roof or randomly. And so there's a fair amount of that on the reused market. Um, so when you have it sandwiched in the rammed earth wall, it's kind of the perfect protector that no bugs, no insects or anything are going to get inside that as long as you do your proper details when you're constructing it. So that's a great way to not use any virgin materials. And that's kind of like the regenerative building piece is trying to find any local material we can. You could also try and do, you could create a space where it makes sense to use cellulose or, many different kinds of materials. It all comes down to how easy or hard it is to construct that, the cavity and putting the insulation in it and having the proper vapor things. But it's pretty open, basically, as to whatever works.
Yeah, I think the idea of insulation, it baffles me a little bit that it's so highly regulated that it has to meet certain values, but that it's not really taking into account the energy that's been input into manufacturing those insulations or the energy that's been input into transporting them. I know that the regulations are probably going to differ across the globe, but there's in my mind, there's this sense of things like lamb's wool or sheep's wool that's a waste product. And then, like you say, even if you're talking about a petroleum product, but it is rapidly available, like hugely available locally, that makes more sense than to go to that checklist of recommended products that are being transported across the globe just to be a sort of ticking that box. So how easy and flexible is it within the building codes to look to use local materials? And is that something that is changing, or is it something that's fairly fixed?
Well, I hope it's changing. It is interesting. We're very fortunate where we live and are working on our projects to not be highly regulated to meet very specific things. There's codes, but in Vermont, they're not enforced. No, there's no organization to enforce them. So it's literally just the contractors are saying that we will, they're liable uh, to be sued if they don't meet the requirements, but then that requires the homeowner to understand there's a problem, be able to find somebody to prove that it is, and then go after somebody and have the finances to hire a lawyer to do it. So it's basically just they're there as good recommendations, and I think they're good to follow the numbers of, and the it's really the numbers and the details around how you construct something. Um, but there are some places where you have to have a stamped number of like this meets XYZ regulations in order to get signed off on your building. And I really hope that those start to change, because there is a tremendous amount of really good material that exists in our buildings today that could be reused if we're wise about it. And there's a great company um, in Vermont here that does deconstruction. Who this is their whole job. They have a crew of people that go out and take these buildings apart, make sure that materials are reused, and there's significant tax benefits to doing it. So and he's always selling everything that he has. It just like it's sold super fast. So there's this place where if we could start to look at that holistic system of like, this is what we really should be doing. How do we create almost like the marketplace that's needed for reclaimed materials, where someone could just go online and say, okay, just like Amazon in the sense of I need a sink, and then they can go on and find the 10 local sinks that might be sitting at various depots around the state, and they say, okay, I want to buy that, and then you have a network of delivery trucks that align orders to bring it to the various areas. Is kind of like a vision that I see, that if we could create that system, um, using what's already been proven by these other people, these other companies that are out there doing it, that we would be able to create significant success. And I think we're in a great time of change where people are willing to see and say like, oh, this kind of makes sense, and willing to support it.
Yeah, I think that anything that we're doing where we're moving towards something that's more regenerative, it does offer such incredible opportunities for innovation and new business opportunities. You've just described something that is in itself simplistic. We know we've got the technology to create a marketplace online. It's just having the minds behind it and the focus and putting the effort into those directions. But they are fairly quick wins, aren't they? When we talk about the scale of construction, if we look at the scale of waste from construction, that must be a huge opportunity for saving of energy.
It really is. There's a lot of materials that get left over at the end of jobs. There's a lot of materials that are ordered wrong. Um, there are a lot of people that are kind of working on that. It's disparate companies, so you could go to one website and find a lot of good materials, um, recycled glass, or like I saw things where you could buy a pallet of glass that was to go into solar panels, but for some reason they didn't meet some specification. Um, so we'd like to explore using things like that on our buildings, so that you could have, those beautiful glass spaces, but it's using single pane glass, which most people are like, well, when I describe the building that we're working on, our prototype, people say, oh, you must going to be doing triple pane windows and the best possible thing. And I say, well, I'd like to challenge the idea. And I think that we can do this with single pane glass, which is a much more readily available material, and just make sure that we have the ability to properly shade and insulate that glass. So instead of making the glass the insulator, when you need to absorb sunshine, you have kind of the visualization that's been helping me is kind of like the stomata of a tree or of a leaf that opens up. It allows the sun or the energy in and moisture, and then that's what these windows could do. You could have shades that roll up, let that sun's energy in, and when it's nighttime and you don't necessarily need to have access to the outside light, it's almost better to have your house close off and not produce light pollution from your house outside into nature. um, you could have those, get to multiple benefits of using those existing materials. You could create a really nice thermal shell that blocks it off, and yeah, you start to reduce your direct impact on the surrounding environment of that building too.
Yeah, this idea of you've touched on it several times, really. This the sort of passive nature of the house in its ability to provide for its own heating needs, its own cooling needs. That is a huge expenditure of energy. How we heat and cool. The building and the materials. We're not just talking about the energy that goes into them, but how they're intelligently designed into the construction so that it becomes something that functions just like you've described, like a tree. A tree lives, it breathes, it adapts. And we don't really think of buildings as adapting. We think of buildings as sort of just, they're just sort of being there. So some of the key, I suppose, ideas with a living building, as you describe them, a living building, that building is going to adapt to temperature, but it's also considering the movement of the sun through the day, the ability for it to have a different reaction to when it's dark and when it's light. How could you sort of sum up a few examples of how a building can adapt to its environment and weather?
So I think being able to, it all comes into the design of um, where you plan to have the most amount of sun at various times a year. So in the wintertime, you may want to make sure that that building has access to as much solar energy as possible. Like there's no shading of the building, but you also have the ability to have some kind of movable shade that should it be a warmer winter than what we expect, we cannot design a building for the average temperature that we want to last for 500 years. So we have to assume that there's going to be times when all seasons when it's too hot or too cold, so having that adaptability of in a winter time period, you may have a hot winter. So you want to start shading more of the sun's energy than what you typically would if it was a cold winter. So that would be a wintertime example. In the summer, it could be, well, we know that we pretty much always want to not have sun, but we might want to have it. So you have like that physical design of it be set up so that it can let up to 50% of the sun's energy come in the summertime in case we happen to have, for some reason, a drastically colder year. You may be wanting winter or summertime heat, but then you have that movable, adaptable shade that can create that shade if needed to have 100% of shading if it is a hotter summer. So if we design our buildings to be able to do just that simple part of being able to um, limit and adapt to how much sunshine it brings in, I think is highly important for us to include into our buildings and have that ability to absorb that sun's energy in there.
Yeah, and in what ways can we absorb the sun's energy? You've made a beautiful explanation of the thermal mass of the rammed earth as the construction wall, but can we sort of add interior elements that will assist in that also?
Yeah, so I think one of the next, you have the passive thermal energy storage in the rammed earth wall that kind of maintains a consistent temperature, but there's definitely going to be times when the sun's not shining for a month. Like we've definitely had that here in the northeast of the US, where a month and a half of basically a couple hours of sunlight in that time period. So that the building is going to act very differently. So we definitely still need to be able to have stored up energy to meet the needs of those kind of spot heating or cooling requirements that buildings might have. So that would be what we refer to as active thermal storage, which might be a hot water tank. So if there's a tank of several thousand gallons that all summer long was heated using thermal hot water, hot water heating panels, and they heat that water up. Typically, our colder time periods, or sorry, not colder, but lack of sun typically comes in November and December. So if your building is kind of charged up from the summertime, the passive energy is charged somewhat, and then you have a large tank of hot water. You can carry into that dark period with using that water through regular heat emitters like we're all used to in our spaces, radiators that just you go in and you want to have it 72 in your room and you can turn it on and it'll warm you up that additional bit. Or also having the ability to use have a wood stove or some kind of wood burning appliance that if you have trees surrounding you in an area, you ideally that building is able to only requires the amount of wood that might be locally available. So if we have a cord and a half of wood that trees that fall or die on the property on a regular basis, we can harvest that locally and keep it there. And for those few times when we really do want that radiant heat, what I picture in some of the buildings, if we're properly designing around the sun, is that when it's sunny out, you have this beautiful open space where you've got a lot of glass. It's a place that you want to be and sit in the sun. And where it really came to me is we used to live in this old mill building, and all of the windows, it was 9 foot tall windows, and they were 6 feet wide, and we had four of them in our apartment. And they were all south facing, single pane glass. This is kind of where a lot of this inspiration came from. And it would be 5 degrees on a winter day, and it would be 80 degrees in our apartment. And my partner and I both at the time worked for an efficiency utility, so everyone is there and is efficient. And they're thinking about how much energy they're using, and we see them on the video calls. They all have their coats on and their hats, and they're inside, and they're inside their efficient house, being bundled up and not necessarily comfortable. And then we would be literally in our shorts and short sleeve t-shirts sitting on the couch getting a suntan, like bathing in the sun. And I was like, there's something here that really, and an architect friend that I work with pointed out, it's like it's living, there's one way of living efficiently, and then the other is living abundantly. And it's living with the abundance of what nature provides. And then when that's not there, you kind of close up that stomata of the building, and then you gravitate towards the back where you have your wood burning appliance or your heat. So you do go into the cave, but when it's cold out, that's the time when you want to kind of go inside and retreat inside. And you have, in that case, you're between a couple rammed earth walls that just give that sense of comfort and warmth.
There's an adaptability there for the human experience, almost like sort of hibernation feeling. So the building in this adaptable manner is actually meeting so many needs that the consistency of a modern home doesn't offer. And I think it's really interesting when we look at the sun, as you've described so much here about that, the sun just in its passive nature, because we can talk about the sun creating energy that is fossil fuels. Millions of years ago, that was sunlight. Then we can talk about the sun providing energy that we can readily burn, but that is actually through sort of plant matter. So it might be like you described, the trees this year have dropped a certain amount of branches, and we can put that in the wood burning stove. But a significant part of what you're talking about here is just that passive, that sunlight in itself heating. The way that works, if you've talked about having single pane glass, and that's allowing a lot of sunlight into the building, even on a winter's day, that's leaving you in your shorts and t-shirts inside. If that then naturally that day, as soon as that sun drops, the temperature is going to drop rapidly because it's a cold month. Does that sort of work hand in hand with the idea that as that temperature outside cools and the sunlight is no longer available, that the building's actually releasing warmth through any sort of thermal mass that it's absorbed during the day?
As long as the thermal shell, the insulation layer, is properly designed, like when I talked about those operable shades that may have insulation built into them that block the glass off, so that you're not relying on the glass to be the insulator. You have something else that's the insulator that might be a better suited thing than trying to cram 3 pieces of glass into to create that insulation layer. So you can certainly keep the heat in. It's just you have to design how to, going back to the stomata example, how do you close off so you create that insulation layer as soon as that happens, as soon as the sun's there, and it's not. But the nice thing about the rammed earth is it really absorbs so much of that energy that it's a constantly radiating 70 or 68 degrees, whatever you have yours, whatever it's set for inside. It's radiating that in all directions. So you don't as long as you close off that glass appropriately, and then you kind of gravitate deeper into the house, then you're more surrounded by those earthen walls. So it's kind of like having a three season, or maybe not three season, but that sun space at the beginning of, or the on the south side of the house that absorbs the sun. So that the temperature in that space is going to be more variable than it would be back in the building. But when you're back in the building, there will be slight variation, but it's going to be a lot longer time frame. So if you don't mind being cold, you could go out into that sun space and still, on a cloudy day, feel sun, but maybe it's 50 degrees instead of 68 back on the other side. So it's kind of creating these two environments, and that's where you can utilize more simplistic materials in that construction if you design those insulation layers, but you create it in a way that's the spaces that you are in that you like to be in.
Yeah. So the building being adaptable, do you advocate using technology within that to monitor the building and to switch it around so that the sort of maximizing the opportunities to close off the light or to allow the light in, or do you try to keep it more simple than that?
I think we need to, with anything that we do today, especially with the built environment, we start with where we are. And if you look at the complexities that we rely on in a building, you can look at that. Most buildings typically rely on like 5 to 6 very complicated, complex systems to keep operational. So the electric grid is an insanely complex real-time delivery of energy that has more. We're closer to the edge of how good that is right now. So it's like a complex, like I try and look at how many complex technologies are we relying on, and there's one common complex technology that we kind of need to go from where we are today to collect the information that helps to iterate designs to get to a place where you have the least complex systems. So the one that I think that we really need is it's the sensory network of our buildings, which is temperature, that distribution of understanding what's happening within the building. So temperature sensors that come in, there's going to need to be some form of intelligence computer on, I think, on each building that's able to read those and then tell, all right, we want the blind closed today, or we know that it's April and these conditions exist, so we need to open up. Like it's this continual learning that'll happen in an evolution of that data to iterate, okay, we know these are how the building works, but I think there's ways to easily integrate kind of more of a natural control. If we get to the place where our homes are where we spend more of our time in, and we're not, the not going and driving to work and being gone from our home and expect it to be warm when we get home, but if we're actually there and part of it more and understanding, there would be ways to start to incorporate simplistic technologies like, oh, it's morning time, I'm going to go over and pull this lever or this cord or whatever, and things start to open up, and you have it designed to do that so you aren't reliant on that complex system. But I think the complex control system we need that kind of the skeleton, the brain and the electrical sensory network that controls everything within that building. I think is what we need, but that's needed in any system. So it's not adding some crazy new system. In order to be in a renewable energy utilizing world, controls are absolutely necessary. The more complex systems we rely on, like fossil fuels and the electric grid and refrigerants and those things, the more complex those control systems have to get, which means, and then that complexity is dependent upon the skilled workforce that can maintain those too. So that's a lot of the thinking that helped me think to like, wow, we really got to get to this less complex way of building, and it's possible. People are doing it and showing that it's possible. I'm not coming up with some new unproven technology.
Yeah, and I think that's the really interesting thing here is there's so many concepts that you're bringing to us that are novel in terms of the way that things are currently done, which is very much the theme that threads through all of the interviews on this show. We're not looking at how it's done and how we can make little improvements. We tend to be looking at how do we tip it on its head and do things completely differently. When it comes to the built environment, that's a little bit difficult for people to take away from this discussion and go and implement it into their lives, because they're not necessarily going to be building a new home. And even if they were, we have this framework. You said it's very actually quite easy to integrate new things where you are in Vermont, but in my experience there's a lot of regulation, and we tend to be moving more in the direction that is fixing the regulation down and increasing this is what we have to do and we need to meet this new standard, rather than the other direction that allows for flexibility and ingenuity in design. So I think it would be interesting if we could just have, I suppose, a little bit of focus on the idea of integrating change into our buildings. Is it possible to move any of the sort of topics that we've touched on today? Do they require a new building from scratch, or can they be moved and sort of retrofitted into an existing home?
Yeah, I believe they can be retrofitted, and yeah, we can. It's very easy to talk about that very idealized building that may be built that can run on one sun year of energy. And this touches back to the point of start where we are. Like you could walk into any building today, and this is the building that exists. What what is the best use? First question is it meeting the needs of the occupants? If those occupants are sick from mold or having to spend a tremendous amount of money and resources to keep it heated and cooled and maintained, to me, that's not meeting the needs of the occupants for that space. And then the question are there changes that can be made to it, or does it make sense to some building, it might make sense to make a change that lasts for 5 years, that makes it meet the needs of the occupants for that 5 years. But during that time, you understand and you take a catalog of all the materials within the building. It has a 10-year-old boiler that may actually still make sense in some other location. And you develop a deconstruction plan for that building and reuse plan for all those materials that could go into that marketplace, right? Like, oh, we have these materials that'll be available in 5 years, and you just kind of put that out there, and then somebody could come along and say, okay, I'm going to need in 5 years, I'm going to plan my own project, which is going to be a larger thing. So that's one step of the decomposition of our existing buildings if they just don't make sense. They don't meet the needs of the occupants. And then there's buildings like the one that I'm in that we've been working on. It was built in the 1850s. It's served 6 to 7 generations already. So what are the decisions we can make today that allow it to properly serve the next, hopefully, 7 generations? And that is making sure we don't just cover something up quickly or throw, one of the biggest things to me is around here, heat pumps are getting put in everywhere because you can just do a direct fossil fuel reduction, but it's adding a system that may only, so right now we're seeing heat pumps be replaced after 15 years. So they don't even last one generation of benefit. And you aren't addressing the problem of the house of the thermal shell. So it's like you go through and you do the holistic approach. How do we make sure we keep water out? How do we deal with humidity and moisture problems so that this building can last? How do we add a nice sun space where we can? We may not be able to be in the perfect south-facing direction, but like on our house here, we have a nice western porch. We could put a sun space on there when the sun is there and available. We may not have the rammed earth to absorb the heat in the same way, but we could have, when that nice sunshine is out there, we open up the windows, we get ventilation. So it's like adding a sun space onto an existing building is like adding a lung and a heat generator. So you could let the windows open up, bring that fresh air and that heat in, and then you kind of close it down. And that building may still need, maybe it needs 5 cords of wood to keep heated. Well, not five. Hopefully you've got down the thermal shell enough that it needs a lot less, but it it still may require more sun years worth of energy. And in some cases, we might still be relying on fossil fuels in certain buildings at certain times of the year because that makes the most sense for that building. Because right now you could burn fossil fuels in your building, like here in the Northeast, people might burn heating oil and they can get 85% efficiency out of that. If that same oil is burned in a generator, it might be 50% efficient of the electrical generation. And then there's all the line losses to get it up to us where we are to run our electrified heating. And it creates grid instabilities. And even though we aren't directly using more fossil fuels, we're indirectly still supporting significant usage of fossil fuel. Um, so it's that way to kind of tie all of those pieces together to reduce the overall amount of sun years of energy, but knowing that if we want to think 7 generations out, it's going to take us 7 generations. Like we've kind of, the built environment has taken 7 generations to get where we are. We're not going to flip it on its head today. We can flip the thinking on its head, but the implementation is going to require a long, holistic thinking process to get us to that place. But if we start doing it today, I think we can have a great chance of altering the built environment in a very positive way.
Yeah, because obviously built environment, it's going to take longer than something that's a much smaller investment to transform. But when we think of innovation in buildings, I kind of feel like it's there for the wealthy. And, you know, these big, impressive, beautiful homes that they have the opportunity to put in new sustainable options in terms of the materials and the technology that's in there. But if we're going to actually make a dent on things, we've got to look at where it really counts is at scale, not at the exception, but the actual norm. Do you feel like that's something that's possible in the longer vision? Or do you feel like, you know, we're sort of still scrambling around with that?
No, it's a very valid point that, especially when you're looking at the higher complexity solutions, it does require a lot of money, right? To buy all of those complex systems that have been built around the world and shipped to you. Um, so that's where I see the the cost coming in. Um, we also have, a workforce that's not it, our built environment. The workforce and the trades that have served the buildings have kind of had the dignity taken away around having pride in our buildings. If you look at older craftsmanship, they took tremendous time to put in those beautiful details. And now it's just a transactional thing. All right, I'm going to go in, I'm going to build a house, we're going to do it, or this building in a year, done, out, and on to the next one. And oh, it's going to be covered up, or like some of those pieces get covered behind sheetrock or whatever. It's just we're not asking for the quality necessarily. We're asking generally for the cheapest thing because we're all limited by money, and it's the unfortunate piece. But the value, or where I see it being possible to change, is when we start to look at the reclaimed materials and the longevity of the materials that we use, especially if it's something that's more local. Like I know that the quarry down the road is going to be there for a long time. Um, I could order a heat pump and that manufacturer may not put that same unit out in 10 years or whatever. And it's so there's like high cost up front for materials that we're going to need to be replaced again in, within a generation or two. And so it really, you have to factor in what that long-term thinking is to really make it beneficial. And what we haven't been able to show yet, because we haven't actually, for our company here in Vermont, we haven't built a rammed earth wall yet. It's been done all over, but we know that there's this way, I think, to create an apprenticeship where you look for those. The apprenticeship is open to those that are passionate for making change. If if they're here to make money, it's probably not going to be the right fit. If you're looking to have this change, be able to learn something, the trades and skills that are needed to build these buildings, you know, those are the people that are going to they're going to find those awesome solutions to, all right, this is how we make this more cost effective. So it's like identifying what's the right thing to do for a building, and then work on the problems that come up to bring those costs down with the eye that these buildings should be for every person. Like that, I see this future where we're able to provide for everyone, regardless of what their income is, buildings that help meet their needs. And I do believe that financially it makes the most sense and is feasible to do with training those young, passionate people they're not there to make a whole bunch of money, so therefore it costs a little bit less, but they're also having an amazing impact in all of what they're doing, and building community too, right? Like really supporting the community by doing that.
Yeah, I think that's a really valid point. I think passion and community are going to be probably some of the key driving factors for change with this, because when we think of the state of our economy, and the more that is sort of becoming uncertain and unstable and the interest rates are rising, the more that impacts the potential long-term vision for the masses. And buildings are a huge investment, so interest rates are going to impact that enormously, more so than our other day-to-day expenses. So we tend to find that the more things become, I suppose, strangulated by that economy, the more we're short-term vision. And that's why I think we've got such inefficiencies in the system of, like you've described, the opportunities with materials and recycling materials. But when you look at the day-to-day and the actual on-the-ground experience, it's probably just, they're on such a deadline and such a tight time frame and a tight budget that there's no movement and no expansion space to innovate. So the movement that we see within regeneration that ties together localization and communities and passionate people driving things forward, that we can really see why that's essential if we're gonna make transformation. And I really want to thank you for being a part of this, because it's clear that you've got that sort of mindset behind you, and it's been a pleasure to learn so much from your work. Is there anything else you'd like to share about how people can learn more from you or get engaged with what you're up to?
I guess, going to our website would be one way, or I'm on LinkedIn too, but or email. I'm happy to share all of that. But livingbuildings.co is the website, and that's all just one word. And yeah, that would be one way to get there and see some of what we're starting to do. And the website is still under development. It's a first draft, and we're working on it. But a lot of these ideas and all of this is really starting to see all of the parts that are kind of like the necessary pieces of the puzzle that I think are needed to be built for the built environment to achieve this vision. And then it's really, trying to find anyone that's passionate about making change. I mean, this is kind of the idea of the apprenticeship. Anyone that's interested in making change, there are so many skill sets needed in the built environment to make this change that it's just a matter of aligning your passion, your skills with where that aligns in the built environment. That could be very different for each person. It could be sitting behind a computer doing some, drawings or whatever, or it might be someone putting new electrical lines in. So really, that's kind of the goal of the apprenticeship. That is this idea, this concept that is in development of opening up that possibility with all the projects that are happening out there in the world. There's a need. There's people that can't quite meet. Companies that don't have the workforce to meet these needs, and there's a lot of people that are really passionate, saying, "Wow, I'm spending a lot of my time doing something that doesn't actually have an impact." So yeah, I guess that's a way of saying if anyone's interested in talking about where or how they might apply like their skills, I would be more than happy to have a conversation about that.
Wonderful. Well, thank you so much. I'll make sure that all of the details for getting in touch with you are in the description so it's nice and easy for people. And again, a great pleasure to learn from you, and thank you for sharing.
Yeah, thank you. I really appreciate the time and having me here.
And thank you for listening to this episode of We Are Carbon. I've had a wonderful response to the animation snippets idea that I introduced in the last episode, so I look forward to updating you on that as things develop further. I'll pop a link in the description if you missed it, and feel free to reach out if you have a suggestion that we might be able to work on for it together. New episodes of the podcast are added every other Tuesday, so don't forget to subscribe to keep up to date. And let's keep figuring this all out together.